Morning, students. Hope you are fine. Good. Today, in physical chemistry group, let's start surface chemistry. In surface chemistry, generally we get 7 marks total. That 7 marks are divided into 5 marks compulsory. Sometimes there will be variation in 2 marks and 1 mark. Sometimes they will ask 1 mark question. Sometimes they will ask 2 marks question. However, the marks will be around 7 marks in this chapter. Okay. In surface chemistry, general surface means what? The chemical phenomena taking place on the surfaces of the substance, objects. Let us take example. After waking up early morning, what we will do? First, we we fresh up. How? By taking a paste and we brushing. When we brush, the dead particles present in the teeth will be removed. That means uh, on the surface of the teeth, we are removing the layers. We are removing the unwanted layer. That is the surface concept. See, another example we can give. Surface means wall. For wall, we put paint. For metals, we put paint. On the surface concept. That phenomenon we will study in this chapter. That type of phenomena. In surface chemistry, day-to-day life, what we surrounding going on, we observe that same concepts. Okay. In surface chemistry, we get generally three parts. The three parts is, according to notes, colloids concept. First part is colloids. Then second part is catalyst. Catalyst. Third part is adsorption concept. Okay. Uh, Adsorption or catalyst or colloids. But these are three parts. From all these three parts, question will be arising compulsorily in examination. First, let's go for uh, this one, colloids concepts. Okay, colloid state. Introduction. What is meant by colloid? Do you know about the colloids? Do you heard the colloids? Don't know. First, it is the Thomas Graham is a English chemist scientist who introduced about the colloidal concept. Generally, what is meant by colloid? Everybody will be get out. Generally, colloids is one of the type of a solution. Solution we call it as simply. That means, see, when we put sugar to water, if you dissolve it, after dissolving the sugar completely dissolves in water and we get a clear solution. Okay, that is a homogeneous solutions. Homogeneous solutions. Can you see the after dissolving the sugar? Can we see the sugar in water? Sugar solution? No, we can't observe the sugar particles in that solution because the sugar molecules are very, very, very less in size, so that we can't observe in naked eyes. Even we can't observe in microscopes also. That much minute particles. That means the particle size is very less. Okay, that type of solutions are known as true solutions. True solutions. Then next type of solutions, take a water, put mud or sand in that, stir it, observe it. The muddy particles, can we observe in water? Can we see in water? Yes, definitely we can. because the sand or mud cannot dissolve in water. Why we are seeing that sand particles or muddy particles in water? Because their particle size are bigger. Hence, we can see that that type of solutions are known as that is suspension solutions. We call it as suspension solutions. Okay. Then see, I give two examples. Sugar solution, I give example. Sand solution. That means when we put sand in water, that sand solutions. Sugar solution we can't observe. Sand solution we can see in our naked eyes. Okay. Sugar solution known as true solutions. This is suspension solutions. But in between these two, true solution and suspension solutions, there is one type of solution. That solutions are known as colloids or salts. We call it as. We also call it salts. Sol. Okay. Let it be. We can further discuss about it. But it then see uh, generally the uh, salts particle size will be 1 nanometer to 1000 nanometers, whereas in true solution less than 1 nanometer. For that, so we can't see here. Uh, Suspensions are greater than 1000 nanometer. Okay, that is the concept. Particle size. Why salts? See, true solution is homogeneous solutions, whereas salts and suspension solutions are heterogeneous solutions. When we put some of the ingredients to water, if we can't see means it is a homogeneous. If we can observe means that is a heterogeneous solutions. Okay. That means physical state changes. That hence we call it as a hetero. Hetero means different. Okay. Then see salts are the can I give example for salts? Example salts means take a what do we call day-to-day life what we use maida. Okay, take a maida pinch of maida and put it in water, stir it. Can maida dissolve in the water? No, that is a salt. That is starch. Maida is nothing but starch. They are extracted from the plant seeds. Hence we call it as it is a starch. That is a starch solution. It also known as starch salt. Got it? Another example, take a egg and raw egg, raw. You break and put it in water and stir. See the status, how the solution will be. The solution will be different. That is means it changes. That is heterogeneous. Somewhat turbidity we get. Okay. In practical part, we come to know that um, gelatinous PPT. That type when egg is put it in water, raw egg, we get gelatinous concept, gelatinous PPT. That is a salt. Okay. That is also known as egg albumin solution. We call it as whatever may be. See another example for salts. Mm, can we observe dust particles or early morning when sunlight falls into the room? you can observe the dust particles will be moving around that. That is also one type of salts. Dust is also a salt. Okay. Uh, uh, if you observe the atmosphere, we get some. We observe clouds. Cloud is also a salt. If anything happens to us, we are not feeling well means we go to hospitals. They will give injections. The medicines what they give, that is also a salts solution type. Okay, there are different. We can see that. Okay, these are the salts. Salts means these are the solutions whose particle size lies between 1 nanometer to 1000 nanometer, in between 1000 nanometer. Sometimes they can explain also in uh, micrometers also. Micrometer, whatever may be. In notes I have given that micrometer. Whatever I'll change I'll change and give. That is nanometer we can. Salt's particle size will be 1 nanometer to 1000 nano. Keep it in mind. Very important concept. The solutions whose particle size lies between 1 nanometer to 1000 nanometer, that solutions are known as salts. Salts, another name is colloids. Okay. See some of the concept. Okay, I explained there. In colloids, generally, in colloids part, see, in colloids part, there is two part. One is dispersion medium. Another is dispersion phase. Okay, dispersion medium or dispersion phase means. I give an example for some. Example, water and maida. What the ingredient we have taken is maida. Maida is a dispersed phase where that medium is water. Dispersion medium and dispersion phase. That means colloids have two parts: dispersed phase and dispersion medium. The solvent what we take is known as dispersion medium. Dispersion medium. The substance what we put that is known as dispersed phase. Keep it in mind. Salts has two parts: dispersed phase and dispersion medium. Next, next concept. It is an intermediate, see definition. It is an intermediate state between true solution and suspension state, whose particle size is usually called as salt. Definition I have given. Keep it in mind. Salts are the solutions whose particle size lies between 1 nanometer to 1000 nanometers. Keep it in mind. In salts, there are two parts: dispersion phase and dispersion medium. See, some of the characteristics of salts. How it nature, how it will be. They are enormous surface area. Okay, they are not detectable even under microscope. They do, they do not settle even under the influence of gravity. They usually carry charges positive and negative. Generally charges. Later we can discuss about these charges. Okay. See, even some of the important questions they have asked in JEE main. See, what are the physical state of dispersal phase and dispersion medium of fourth? Fourth means what? In Kannada we call it as nore. ಈ ಸೋಪ್ನ ನೀರಲ್ಲಿ ಹಾಕಿ ಸ್ಟರ್ ಮಾಡಿದಾಗ ಶೇಕ್ ಮಾಡಿದಾಗ ನೊರೆ ಬರುತ್ತೆ ನೋಡಿ. ಈಗ ಬಟ್ಟೆ ಒಗೆಯುವಾಗ ನೀರು ಹಾಕೊಂಡು ಸೋಪ್ ಇದ್ದಾಗ ಬಬಲ್ಸ್, ಏರ್ ಬಬಲ್ಸ್ ನೊರೆ ಬರುತ್ತೆ ನೋಡಿ, ಅದನ್ನ ಫ್ಲೋಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದರಲ್ಲಿ ಫ್ಲೋಟ್ ಅಲ್ಲಿ ದಟ್ ಈಸ್ ಫೋರ್ತ್ ಆಲ್ಸೋ ಒನ್ ಟೈಪ್ ಆಫ್ ಕೊಲೈಡ್ಸ್. Fourth is a mass of bubbles in liquid that is caused by agitation. That means agitation means ನೀರಲ್ಲಿ ಸೋಪ್ ನಿಂಗ ಹಾಕಿದಾಗ ಸೋಪ್ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಡಿಸಾಲ್ವ್ ಆದಾಗ ನೊರೆ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಅದನ್ನ ಎಜಿಟೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅದರಲ್ಲಿ ಆ ನೊರೆಯಲ್ಲಿ ಯಾವ್ದು ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್, ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ನೋಡಿ. ಅಲ್ಲಿ ವಾಟರ್ ಉಪಯೋಗಿಸಿರ್ತೀವಿ, ಅಲ್ಲಿ ಅದಕ್ಕೆ ಅದನ್ನ ಲಿಕ್ವಿಡ್ ನ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಅಂತ ಕರಿತೀವಿ. ಅಲ್ಲಿ ಬಬಲ್ಸ್, ಗೇರ್ ಬಬಲ್ಸ್ ತರ ಬಂದಿರುತ್ತೆ. ಆ ಗ್ಯಾಸ್ ನ ಡಿಸ್ಪರ್ಷನ್ ಫೇಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ದೆನ್ ಸೆಕೆಂಡ್ ಒಂದು ನೋಡಿ, ವೈ ಮೆಡಿಸಿನ್ಸ್ ಆರ್ ಮೋರ್ ಎಫೆಕ್ಟಿವ್ ಇನ್ ಕೊಲೈಡಲ್ ಸ್ಟೇಟ್. ಅಲ್ಲ, ನಾವು ತಗೊಳ್ಳೋ ಮೆಡಿಸಿನ್ಸ್ ಆರ್ ಆಲ್ಮೋಸ್ಟ್ ಕೊಲೈಡ್ಸ್. ಈಗ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಬೇಕಾದ್ರೆ ಒಂದು ಟ್ಯಾಬ್ಲೆಟ್ ತಗೊಂಡು ನೀರ್ಗೆ ಹಾಕಿ, ಯಾವ್ದಾದ್ರು ವೇಸ್ಟ್ ಆಗಿರೋ ಎಕ್ಸ್ಪೈರ್ಡ್ ಆಗಿರುವ ಮೆಡಿಸಿನ್ಸ್ ನ ಒಂದು ಗ್ಲಾಸ್, ಚಿಕ್ಕ ಗ್ಲಾಸ್ ತಗೊಂಡು ಹಾಕಿ ಡಿಸಾಲ್ವ್ ಸ್ಟರ್ ಮಾಡಿ ನೋಡಿ ಹೆಂಗ್ ಕಾಣಿಸುತ್ತೆ. ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ಕೊಲೈಡಲ್ ಫಾರ್ಮ್. ನಮ್ಗೆ ಕನಕ್ ಪೂರ್ತಿ ಡಿಸಾಲ್ವ್ ಆಗುವುದಿಲ್ಲ, ಅದು ಪೂರ್ತಿ ನಮ್ಗೆ ಸಸ್ಪೆನ್ಷನ್, ಆವಾಗಲೇ ಸ್ಯಾಂಡ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳಿದ್ರೆ ನೋಡಿ, ಆ ತರ ಕಾಣಿಸಲ್ಲ, ಇನ್ ಬಿಟ್ವೀನ್ ಇರುತ್ತೆ. ಓಕೆ, ಅಲ್ಲಿ ಸ್ಯಾಂಡ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಸ್ ವೆರಿ ಬಿಗ್ಗರ್, ಮೋರ್ ದನ್ 1000 nanometer, ಬಟ್ ಇಲ್ಲಿ ಲೆಸ್ ದನ್ 1000 nanometer ಅಂಡ್ ಗ್ರೇಟರ್ ದನ್ 1 nanometer. ಅದರಿಂದ ನಮ್ ಕಣ್ಣು ಕಾಣಿಸುತ್ತೆ ನೋಡಿ. ಅಲ್ಲಿ ಕ್ವಶನ್, ವೈ ಮೆಡಿಸಿನ್ಸ್ ಆರ್ ಮೋರ್ ಎಫೆಕ್ಟಿವ್ ಇನ್ ಕೊಲೈಡ್ ಸ್ಟೇಟ್. See, salts particle, sorry, particles of colloidal state has a larger surface area and thus show more effective absorption. So, if medicine is called as, hence it is called as colloidal state, and we get better results there. Because blood is also a colloidal form. Colloidal state, blood is also. That colloidal particles will be get absorbed. Absorption takes place when medicine enters to our bloodstream. That medicine easily absorbed. Okay. Hence the what we take medicines, the medicines also a colloidal form only. Okay, when we take the tablet or injections also, they will take the if liquid in statements, they will directly inject. They take syringe and they suck the injection liquid from the medicine bottle and directly inject. Or otherwise, if you take a tablets, if you take the tablet in your stomach, it dissolves and it exists in a colloidal form. That colloidal form will be absorbed by the villi and transported to the bloodstream. In that bloodstream, it get absorbed in colloidal form. Okay, almost all medicines are in colloidal state only. Okay. Okay. Today we can stop here. From tomorrow onwards, let's continue another concept. Okay. Don't worry. Yesterday and today we are trial and error. We are doing how much we can possible. We can trial and error. Okay, pa. Thank you. Bye. Be careful.